Welcome to the AWS Certified Cloud Practitioner Prepcast, where we guide you through everything you need to know for your certification exam. Whether you're just starting or looking to refine your knowledge, this course will set you up for success. Brought to you by baremetalcyber.com. Let's get started. When organizations connect their on-premises networks to AWS, they often seek private, secure, and reliable pathways. Two primary options stand out: VPN and Direct Connect. A VPN, or Virtual Private Network, uses encrypted tunnels over the public internet to connect corporate environments to AWS resources. Direct Connect, by contrast, provides a private, dedicated link into AWS, bypassing the public internet entirely. Both serve the same goal, linking on-premises systems with the cloud, but they differ in performance, cost, and complexity. VPN is faster to set up and offers encryption by default, making it ideal for smaller or temporary workloads. Direct Connect provides predictable bandwidth and lower latency, often required for enterprises migrating heavy workloads or meeting compliance requirements. Together, they provide a flexible toolkit for hybrid connectivity. A site-to-site VPN in AWS uses IPsec tunnels to create encrypted pathways between a customer's network and a VPC. These tunnels are established between a customer gateway, the device or software on the customer's side, and a virtual private gateway, VGW, or transit gateway, TGW, on the AWS side. IPsec ensures that data passing over the public internet remains secure and unreadable to outside parties. Typically, AWS provisions two redundant VPN tunnels, so if one fails, the other takes over. This redundancy ensures high availability, even though the connection still depends on internet reliability. For businesses needing a secure, quick-to-deploy bridge to AWS, site-to-site VPN provides a straightforward solution that requires no physical infrastructure changes beyond configuring the local gateway device. Transit Gateway expands VPN's utility by allowing multiple VPCs and on-premises networks to connect through a central hub. Instead of creating individual VPNs for each VPC, a Transit Gateway VPN attachment provides a scalable hub-and-spoke model. This reduces management complexity, especially for large organizations with dozens of VPCs. Static or dynamic routing options are available, with dynamic routing using BGP, the Border Gateway Protocol, to exchange routes automatically. Static routing is simpler but less flexible, requiring manual updates when networks change. For example, a global enterprise might use BGP to simplify managing thousands of routes across multiple regions. Transit Gateway with VPN attachments transforms VPNs from simple point-to-point links into part of a broader hybrid network strategy. Routing itself is a key aspect of VPN design. Static routing locks traffic to predefined paths, while dynamic routing via BGP allows routes to adapt automatically. BGP provides failover by quickly rerouting traffic if one tunnel or path goes down. For example, if a company's primary tunnel fails, BGP advertises a backup route, and traffic continues without human intervention. This adaptability is crucial for hybrid environments where reliability is essential. On the exam, scenarios describing resilience and route adaptability typically point toward BGP, while simpler, fixed connections point toward static routing. Understanding this distinction ensures designs remain both functional and robust. High availability patterns in VPN deployments often involve tunnel redundancy. AWS provides two tunnels by default, and best practice is to configure both on the customer side, spreading them across different devices or links if possible. For instance, one tunnel might traverse one ISP while the second uses another, reducing the risk of a single provider outage. This dual-tunnel setup provides resilience at the network level, ensuring secure connectivity even when parts of the public internet fail. Although VPNs cannot eliminate the variability of internet latency, redundancy ensures they remain reliable enough for many business-critical but moderate throughput applications. Beyond site-to-site options, AWS offers Client VPN for secure remote user access. Client VPN provides an encrypted connection for individual users, allowing employees to securely access VPC resources from laptops or other endpoints. Unlike site-to-site VPN, which connects entire networks, Client VPN extends AWS connectivity down to the individual user level. For example, a remote developer might use Client VPN to connect securely to internal tools hosted in a VPC. This service supports multi-factor authentication, integrates with IAM and directory services, and ensures that workforce mobility doesn't compromise security. While not central to hybrid networking, Client VPN plays an important role in secure distributed workforces. Direct Connect, or DX, provides a very different model of connectivity by establishing a dedicated private line into AWS. This connection bypasses the public internet entirely, delivering consistent performance, lower latency, and predictable bandwidth. Enterprises often use DX when migrating large datasets, running latency-sensitive applications, or meeting compliance requirements that discourage or prohibit reliance on the public internet. Direct Connect is provisioned at AWS Direct Connect locations, where customers or partners physically establish the link. The service offers speeds ranging from 50 megabits per second to multiple 100 gigabits per second connections, far exceeding typical VPN throughput. While setup is more complex and time-consuming than VPN, the result is a highly stable bridge to AWS for enterprise workloads. Direct Connect operates through virtual interfaces, or VIFs. Private VIFs connect directly to VPCs, enabling access to private IP ranges. Public VIFs, by contrast, provide access to AWS public endpoints such as S3 or DynamoDB using AWS's backbone rather than the open internet. For example, a company transferring large volumes of data to S3 might use a public VIF to ensure consistent performance without internet variability. Hosted connections allow customers to provision DX through partners, providing flexibility without building full physical infrastructure. For high-demand use cases, multiple DX links can be aggregated with link aggregation groups, or LADs, improving both capacity and resilience. Resilience in Direct Connect requires planning for diverse physical paths and locations. A single DX connection, while private and stable, still represents a potential single point of failure. Best practice is to provision redundant connections in different facilities or through different providers, ensuring continuity during outages. For example, a bank might use 2 DX connections in separate metropolitan areas, maintaining uptime even if one site experiences disruption. This diversity ensures Direct Connect lives up to its promise of enterprise-grade reliability, matching the expectations of workloads where downtime could have severe consequences. Often, enterprises combine Direct Connect with VPN to balance cost, performance, and resilience. Route priority allows DX to act as the primary path, while VPN provides encrypted backup over the internet. If DX fails, traffic reroutes automatically through the VPN, maintaining connectivity. This hybrid approach leverages DX's stable, high-performance link while ensuring no single point of failure. For example, a multinational might rely on DX for predictable workloads but configure VPN tunnels as an automatic safety net. This pattern demonstrates AWS's philosophy: no service operates in isolation. Strong designs use combinations to maximize reliability. Encryption is another consideration, as DX itself does not provide encryption by default. For sensitive workloads requiring confidentiality, organizations often deploy IPsec VPN over Direct Connect, layering encryption on top of the private link. This combines DX's performance benefits with VPN security guarantees. For example, a healthcare provider might transfer patient data over DX with an added VPN overlay, ensuring compliance with regulations. This flexibility allows Direct Connect to meet both performance and security requirements, depending on the workload's risk profile. Monitoring paths in both VPN and DX setups is vital to maintaining reliability. AWS CloudWatch provides metrics on tunnel status, packet drops, and throughput. Alarms can notify administrators of degradation, allowing quick response. For example, an alarm could alert a team if DX latency spikes, prompting traffic to shift temporarily to VPN. Without monitoring, failures may go unnoticed until users are affected. With it, hybrid links become observable, measurable systems where reliability is actively managed. Monitoring ensures that connectivity isn't just provisioned, but maintained as part of daily operations. The cost models for VPN and DX differ significantly. VPN costs are generally modest, with charges based on data transfer and hourly fees for virtual gateways. DX, however, introduces costs for physical port capacity, data transfer, and additional features like lags. For example, a 1 gigabit per second DX port incurs a fixed monthly fee, regardless of usage, plus per gigabyte transfer charges. This makes DX more expensive up front, but potentially more efficient for high-throughput workloads. VPN is cost-effective for smaller or variable workloads, while DX becomes economical at scale. Understanding these signals helps organizations choose the right service based on both budget and technical needs. From an exam perspective, the key is identifying when to use VPN, Direct Connect, or standard internet. If the scenario emphasizes speed of setup, encryption by default, or temporary connectivity, VPN is the answer. If it emphasizes consistent bandwidth, lower latency, or compliance requirements, Direct Connect is appropriate. When both resilience and performance matter, a hybrid DX plus VPN design provides the best solution. Recognizing these patterns allows learners to map requirements to services confidently, both for the exam and for real-world architectural choices. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Choosing the right connectivity method often comes down to latency, throughput, and compliance needs. Site-to-site VPN provides rapid deployment and built-in encryption, but because it runs over the public internet, latency and bandwidth are unpredictable. Direct Connect offers consistent throughput, typically from hundreds of megabits to multiple gigabits per second, and lower, more stable latency by using AWS's private backbone. For compliance-driven workloads like healthcare or financial services, DX often satisfies requirements that prohibit reliance on public internet. However, many organizations use both, DX for predictable performance, and VPN as a resilient backup or for branch offices without DX access. By aligning connection type with performance, cost, and governance needs, architects ensure hybrid links remain both effective and compliant. Transit Gateway expands hybrid design by enabling hub-and-spoke architectures. Rather than creating many VPN or DX links directly into individual VPCs, TGW centralizes connectivity, attaching VPCs, VPNs, and DX links in one place. This model reduces operational complexity, allowing hundreds of VPCs to connect securely through a single point of management. For example, a multinational enterprise could use TGW as its central hub, with on-premises data centers connected via Direct Connect and regional offices via VPN. This hub-and-spoke model simplifies routing, improves scalability, and ensures policies can be applied consistently. It's a foundational pattern for organizations with complex hybrid or multi-region footprints. Overlapping CIDR ranges are a common pitfall in hybrid networking. If an on-premises environment uses 10.0.0.0/16 and a VPC is configured with the same block, routing conflicts occur. Packets cannot determine which destination to reach. Remediation often involves renumbering one environment or carefully segmenting ranges with NAT translation, but these are painful and disruptive. Best practice is to plan IP allocations early, ensuring AWS VPCs avoid overlaps with corporate or partner networks. This foresight prevents connectivity issues that can stall hybrid adoption. For learners, remembering that IP overlap equals routing confusion is both an exam tip and a real-world lesson. Route propagation and filtering provide flexibility in how networks share routes. With BGP, routes can be automatically propagated into route tables, reducing manual configuration. Filtering allows administrators to accept only specific routes, preventing accidental or malicious advertisements from impacting traffic. For example, a VPN may advertise all corporate networks, but AWS administrators might filter to only accept certain ranges, ensuring control. This combination of propagation and filtering balances automation with safety, ensuring connectivity remains dynamic without becoming reckless. For exams, dynamic propagation usually signals BGP, while static configurations point to manually maintained routes. Direct Connect supports both private and public VIFs, and understanding their use cases is essential. Private VIFs connect to VPC resources, enabling secure, private communication with instances, databases, and services inside the VPC. Public VIFs, by contrast, provide access to AWS public endpoints like S3 or DynamoDB across the backbone, improving performance and reliability compared to the public internet. For example, a company moving terabytes into S3 each night may benefit from a public VIF to ensure consistent throughput. Choosing between them depends on whether the workload needs private VPC communication, faster public endpoint access, or both. Many enterprises use multiple VIFs to cover these scenarios. Private Link introduces an alternative to routing-based designs by allowing private connectivity to specific AWS services or partner applications through interface endpoints. Instead of opening network paths broadly, Private Link restricts access to a service presented within the VPC. For example, instead of exposing a payment processor through public internet routes, Private Link creates a private endpoint that applications can connect to. The trade-off is granularity. Private Link is ideal for targeted services, while routing through DX or VPN is better for broad network communication. Recognizing when to use Private Link versus traditional routing is an exam cue and a key architectural decision. High availability requires thoughtful reference patterns. For VPNs, this often means configuring both tunnels, potentially across different customer gateways or ISPs. For DX, resilience requires redundant links in diverse facilities or geographies, often combined with VPN as a backup. For example, an airline might use two DX links in different cities to ensure resilience, with VPN as a fallback. These patterns emphasize that no single link should be considered unbreakable. True reliability comes from layering redundancy, whether through tunnels, links, or combined architectures. Security groups and network ACLs remain critical even when hybrid links are established. A VPN, or DX, may connect networks, but access control still governs which resources can communicate. For example, a database in a private subnet should still restrict access to only the application tier, even if on-premises systems have network reachability. This alignment ensures hybrid connectivity does not inadvertently widen attack surfaces. By treating security controls as layered and persistent, organizations prevent the backdoor effect, where hybrid connections bypass intended protections. Change control and maintenance are operational realities for hybrid links. VPN tunnels may reset during maintenance or renegotiation, and DX circuits may require scheduled downtime for provider upgrades. Clear communication, documented maintenance windows, and rollback plans ensure disruptions are anticipated rather than surprising. For example, a migration runbook might specify how to temporarily reroute traffic over VPN during DX maintenance. Change control transforms networking from reactive firefighting into proactive, predictable operations, maintaining trust across technical and business teams. Troubleshooting hybrid connectivity often comes down to BGP states and tunnel health. Administrators monitor whether BGP sessions are established and routes are being advertised correctly. Tunnel status confirms whether IPsec negotiations succeeded. For example, if traffic isn't flowing, examining BGP advertisements might reveal that prefixes aren't being shared, or logs may show failed encryption handshakes. Knowing where to check BGP states, routing tables, or tunnel logs is a critical skill. AWS provides telemetry through CloudWatch, but customer devices also supply vital diagnostic information, making troubleshooting a shared responsibility. Logging adds accountability and visibility to hybrid links. Flow logs provide metadata about traffic traversing VPCs, showing which IPs and ports communicate. Device telemetry from on-premises gateways reveals tunnel stability and throughput. Together, these logs form an end-to-end picture of hybrid behavior. For example, a spike in dropped packets in flow logs combined with errors in device logs might indicate mismatched encryption settings. Logging ensures issues are not only detected but understood, enabling corrective action before users experience major outages. Disaster recovery planning extends hybrid designs across regions. Cross-region connectivity ensures workloads remain accessible even if a region suffers a major outage. For example, a multinational may maintain DX links into two separate regions, replicating data across both. VPN tunnels provide additional continuity by routing traffic if a DX or region becomes unavailable. Planning DR connectivity ensures not just workload recovery but user reachability, turning AWS into a resilient extension of enterprise infrastructure. For exams, DR scenarios often hint at multi-region 510 or VPN configurations as the correct choice. Cost governance is essential in hybrid networking. DX port fees are fixed, so unused capacity wastes money, while VPN costs can spike with high data transfer volumes. Forecasting practices, such as estimating expected throughput and modeling failover scenarios, prevent surprises. For example, traffic shifting to VPN during a DX outage may temporarily increase internet egress costs. By modeling these scenarios, organizations budget realistically and avoid billing shocks. Governance transforms cost from a variable surprise into a predictable, managed factor of hybrid operations. Documenting hybrid connectivity through baseline diagrams and runbooks ensures teams operate consistently. Baselines capture CIDR allocations, route policies, and endpoint configurations, while runbooks define how to respond to failures or cutovers. For example, a runbook might specify how to test failover from DX to VPN quarterly. Documentation prevents institutional knowledge from residing in individuals, heads, ensuring continuity across teams. It also aligns with compliance and audit requirements, demonstrating control over hybrid environments. From an exam perspective, keywords often reveal the right choice. If the question emphasizes rapid setup, encryption, or internet-based connections, VPN is correct. If it emphasizes consistent bandwidth, low latency, or compliance requirements, Direct Connect is the answer. If it mentions resilience with both, the hybrid DX plus VPN pattern applies. For advanced cases, references to private link or transit gateway point towards specific architectures. By mapping keywords to services, exam takers can quickly identify the correct option, mirroring the reasoning used in real-world design. In conclusion, AWS hybrid connectivity offers flexible pathways through VPN and Direct Connect, each suited to different needs. VPN provides agility, encryption, and low entry costs, while DX delivers stability, performance, and compliance alignment. Transit gateway, private link, and layered architectures extend these options, offering resilience and governance at scale. By aligning choices with latency, throughput, cost, and regulatory drivers, architects ensure hybrid environments remain both secure and reliable. For learners, the key takeaway is simple but powerful. There is no single best option, only the right one for a given requirement, always with redundancy built in. That concludes today's episode of the AWS Certified Cloud Practitioner Prepcast. Be sure to tune in for the next episode and visit us online at baremetalcyber.com or cyberauthor.me for more resources, including news, mailing lists, YouTube videos, podcasts, and much more.